Hello Pure Maths 3 students. We're carrying on this week with exercise 5.4. We did questions 1 to 5. Last week we're going to continue on and finish the exercise this week. I'm going to do one example from this exercise, at least for now, and to help you refresh your memory on what you learned last week. Just a couple of heads ups. First of all, you'll notice that we are not going to be doing exercise 5.5, which is on using the trapezium rule, because that's no longer in the syllabus, so we're not going to spend time covering that. You are going to go straight on from this exercise into the summary exercise. So anything that deals with the trapezium rule in the summary exercise, you're going to need to make sure you just ignore that, unless of course you're interested in, and you feel like you've got heaps of time, which I doubt at this point of the year. Okay, so I'm using this time to look at exercise 5.4 number 10, and I am trying to show that 1 minus tan squared x over 1 plus tan squared x is equal to cosine 2x. My first step in this is I'm going to say on the top I'm going to have 1 minus, and I know using this identity here that tan squared x is sec squared x minus 1. And I'm going to do much the same kind of thing on the bottom. 1 plus, now tan squared x is sec squared x minus 1. And if we simplify this, we're going to get 2 minus sec squared x all over sec squared x. Now, next step, that is the same as 2 over sec squared x minus 1. What I've done here is I've put the 2 over sec squared x as my first term, and the minus sec squared x over minus sec squared x gives me my minus 1. Now I know that 2 over sec squared x is the same as 2 cosine squared x, since sec squared x is 1 over cosine squared x. So that's how I've got that, minus 1. And I note at this point that this is an identity here. You can see that that's the same as cosine 2x. So that's the first part of the question. Okay, now part 2, part B, we are now going hence. That means I'm going to use what I've just learned to do the integral of this one here, pi over 6, between pi over 6 and 0. Now, what have I got here? I've got 1 minus tan squared x, 1 plus tan squared x. Okay, so this bit here is what we've just found is equal to cosine 2x. But you'll note that this time it's squared, so I'm going to go cosine 2x squared. Okay, now remember we can't do integration of these squared functions, so we're going to have to use some kind of rule to get it into a form that we can integrate. Now I'm going to use the cosine 2a rule here. So I'm going to say cosine 4x is equal to 2 cosine squared 2x minus 1. Okay, I'm just basically using this rule here, but instead of a, I'm using the 2x that I've got here. Alright, if that's the case, then cosine 4x plus 1 is equal to 2 cosine squared 2x, and I'm going to say therefore that cosine squared 2x is equal to 1/2 cosine 4x plus 1/2. Now this here is what we have here. So now I've got it in an integratable form. So between 0 and pi over 6, I'm going to integrate 1/2 cosine 4x plus 1/2 dx. And I might just fix this up because it looks a bit dodgy at the beginning there. Okay, so it's going to be 1/2 times cosine 4x. Okay, so let's do that. What do we get? Okay, so we're going to have 1/2 multiplied by, using our rule over here, 1 over a, 1 over 4, sine 4x, and plus 1/2 x. And we're going to do that between 0 pi over 6. Now when I do this on my calculator, I am getting, for this first one, let's have a look, square root 3 over 16 plus 1/12. And then when I stick in 0 as my x, I'm going to get 0 for my second term. So my final answer is simply this bit here. Okay. The second one that we have to do, C, is, you'll note the reciprocal of the first one in part B that we've done. So it's the reciprocal. So in that case, instead of a cosine 2x squared, we're doing a sec 2x squared. Okay? Because the reciprocal of cosine is sec. So I'm going to do between pi over 6 and 0, I'm going to integrate sec squared 2x, like that, dx. Now this is nice and easy peasy. We're using this formula here. So I put my brackets in like that. I'm going to have 1/2 tan 2x and between 0 and pi over 6. Now, if I chuck this in my calculator, the first one is going to be 1/2 tan pi over 3, because it's 2 times pi over 6. And when I do that, I get square root 3 over 2. And then when I chuck a 0 in, tan 2 times 0 is tan 0, and we know tan 0 is 0, so I'm going to be subtracting once again 0. So actually this is going to be my final answer, square root 3 over 2. Well, there you go. There's another example done. Keep on thinking very hard about what you're trying to achieve, which is you want to get these trigonometric functions into an integratable form. And for you guys, what we're trying to achieve in that is we want to have them in a form like one of these ones down here. Okay, keep working at these. Let me know if you're having any difficulties. Take care.